So we're going to start with just an introduction into how to solve an inequality, what an inequality is. So we're going to do a little intro. We're going to do some more translating too. Translating. Okay? So if you're watching a video on something else or you're working on someone else's homework or anything like that, please make sure that you put that away. And we're doing math now. You're doing math. Okay. So over the last couple of days, you have really, gotten good at solving equations, haven't you? Really good. Sure, or not. We'll see. I'm going to grade your quizzes today during 7th period. I don't joke. No. I'll get your quizzes graded, and they'll be in Power School by the end of the day. You'll get them back tomorrow. You're welcome. Okay, but with equations, what we did was we had an equal sign. That's what an equation means, equals. It's kind of in the word a little bit. We're going to divide by 2, x equals 5. Pretty easy, right? Okay. Now today, we are going to do inequalities. And inequalities are not just going to have one answer like that. It's going to have an infinite amount of answers. Or it could have no answers, and we're going to get to that too. So if you have an inequality, all they do is they change the sign on you. It could be greater than, less than, greater than or equal to, or less than or equal to. And it's solved the same way, right? Just divide by 2, and x is bigger than 5. Okay. So this has an infinite amount of answers, because there's an infinite amount of numbers that are bigger than 5. All right. So let's go ahead, and I'm going to show you an inequality. We're going to have it written in math language or symbols. Then we're going to write it as a word sentence. A word sentence. And we're going to do some graphing. I know. But no, not the kind of graphing that you hate with the XY plane. We're not doing that till next chapter, so don't worry. We're just going to be graphing on a number line. Basic, yeah. Like 3rd grade stuff, right? Okay, so here we go. Suppose that you have the inequality that looks like this. And I'm not going to say it out loud because I'm actually going to write it in words in just a minute. And if I say it out loud, those are the words. So how would you write this in a word sentence? You would say what?
X bigger than 4.
Perfect. Bigger than? Or I'd probably use a different word.
Greater than.
Yeah. You're right. I'm right. X is greater than 4. Perfect. Can you think of numbers greater than 4?
6.
6 is greater than 4. What else?
35.
35. Mm-hmm.
6.1.
What else is greater than 4, but just by a little bit? 4.05. Ooh, that's a good one. Oh, yes. Nice. I was going to say that, too. Okay. That brings us up to graphing. 0, 1, 2, 3, 4. Okay, if I wanted to graph this on a number line, and I want to represent all the numbers that are bigger than 5, or 4, sorry, 4. I'm not going to start at 5, because then I'm going to miss a whole bunch of numbers that you two were talking about, right? I'm going to miss an infinite amount of numbers between 4 and 5, and then I have an infinitely wrong answer. Okay, so this is how we get around this. Does anyone remember doing this? You're going to draw an open circle around 4. Oh, the groans, there they are. And we're going to go to the right. Okay, so that right there, that open circle says just after 4. If I started it at 4.5, I'm still missing numbers. If I started at 4.1, I'm still missing numbers. So you draw an open circle around 4 to the right. All right, how about this one? Okay, write that down, yeah? Write that symbol down. I added a little thing. I flipped it, flipped the sign, and then I added a little bar at the bottom. So how do we represent that as a word sentence? Yes. Perfect. Yep, you said it right. X is less than or equal to. And the key word there is or equal to. Because I had or equal to 4. We should say 4. I had a student say, oh, but it's only 4. And I'm like, no, but you're like, equal to 4, but I said, no, it's or, okay? So it's either less than or it could be equal to 4. And how do we represent that graphically? Closed circle, 1, 2, 3, 4. Yeah, you're going to close that circle, put a solid dot at 4, and it's all the numbers that are to the left. Just kidding. No. Okay, no Beyonce for Wyatt. Okay, fine, Wyatt. Haters gonna hate. All right, so let's go ahead and just write a rule for this. We're going to write a rule for this. If you have less than, greater than, we're going to graph with an open circle. Okay? And if you have less than or equal to, greater than or equal to, we're going to close that circle in. When we get to graphing lines, the open circle on a graphing line is a dashed line. Do you remember dashing and shading? Yeah. The closed circle is a solid line. It includes that boundary. So we'll get to that chapter 2, lesson 7. Don't worry about it. All right, now let's do some translating. How'd you do on the quiz? Did you get CD minus 5?
Yeah.
Good. You got one right.
Transcontinental.
Translate. 5 fewer than the product of C and D. The product of C and D is CD. 5 fewer than that would be 2 minus 5, not the other way around. Okay? All right, we're going to translate some inequalities, though. So here we go. Number 1. We're going to do 2 of them. 5 fewer than a number. 5 fewer than a number is at least 12. So what we're going to do is we're going to, you've been writing, translating expressions. There's no equal sign. There's nothing to do there. It's kind of something just sitting there, an algebraic expression. This one's going to be an algebraic inequalities. It's going to involve a little bit more. The first sentence is the stuff that you've done already. Or not the first sentence, the first section of the sentence. 5 fewer than a number. And stop right there. How do you represent 5 fewer than a number? Yes? Perfect. X minus 5. Everyone likes to use X. You can use any letter you want. You can use A for Andrew. You can use M for Maddie. You can use whatever you want. All right, 5 fewer than a number is at least 12. Okay, here's the tricky part. If this number right here, this X minus 5, is at least 12, that means it's what? Greater than or equal to 12. Yes. The number that we're talking about is at least 12. So it could be 12, 13, all the way up, even decimals. It's like this. PG-13. Who can go see who can go see a PG-13 movie legally?
I can see it rated R.
Good for you. And what is rated R now? Is it 18? 17.
Just
okay.
kidding. I'm still 16.
Oh, okay. Do they card you?
Yeah.
Or you go to the little thing, not the legal, the electronic ones, and then you just say it together.
Oh, wow. Don't listen to that. Don't hear that. Okay, number 2. You try this one. You try this one. Shh, shh, shh. Okay, how about the product? The product of 7 and a number is no more than 50. The product of 7 and a number is no more than 50. You try this one, okay? You write what you think it is, and then look to your neighbor and see if you have the same thing. It's okay to do that. Not on a quiz, though.
Oh, that's all I discussed when I was young.
That would be cheating.
I thought it was working together.
No, networking. It's just networking with my partner.
Yep.
The product of 7 and a number is no more than 50. I actually got this one wrong yesterday, and then my class, they kind of convinced me that I was wrong, and they were right. And it's funny because I had the right answer on my paper, but I just wrote it down wrong. The product of 7 and a number. Ooh, I can do that. What'd you use, X? The product of 7 and a number means 7 times X. Is no more than 50. So what's the sign? Yes, you did it. I said less than yesterday, and they were like, no, it's less than or equal to, and they were right. So the product of 7 and a number is no more than 50. Okay? No more than 50. All right, let's move on.
So it's set.
Yep, less than or equal to. Part B. Part B. Now what we're going to do is we're going to solve and graph. We're going to solve the inequality, and we're going to graph our solution. And I have 5 examples for you. 4 just regular problems, and 1 is a word problem. Solve and graph. Now here's the thing that I was talking about earlier when I said, Inequalities work the same way as equations, except there's one little thing that happens. If you were to take an inequality and you're going to divide or multiply by a negative number, do you remember what happens when you divide or multiply by a negative number? Yes, flip the gator. You got to flip the sign.
I tried to flip an alligator.
You did? I'm not that daring, so I'm just going to flip signs. Not like gang signs or anything, but, you know, symbols. So I would never flip a gang sign. All right. Divide or multiply by a negative number, flip the sign. Okay, now your math teachers probably told you that before. Maybe you remembered it, maybe you didn't. And you just accepted it, right? Because math teachers, you accept everything they tell you. Did you ever question why, though? Like, why does that happen?
Yeah.
Yeah?
I say why all the time.
You do?
Because I'm sad.
Oh. Let me just show you, it's not really a proof or anything. It's just a quick way to see why it works, okay? So, we all know that 2 is less than 4, right? 2 is less than 4. What happens when I divide both sides by -1 or multiply by -1? This becomes negative. That becomes negative.
It's no longer the same.
Yeah, okay. So then what happens is -2 is greater than -4. So everything gets flipped around when you do it that way, right? Okay. So now you kind of know a little bit why. But if you ever want to know why of something, ask. I might know. Number 3.
Why?
My 5-year-old likes to ask why a lot.
Same.
-3 times 2x minus 5 plus 1 is greater than or equal to 4. All right, just like equations, those of you who love to show work out there, if you want to get full credit on your homework, you're going to write down the inequality and you're going to show work and solve, okay? If you don't want, if you don't want full credit on your homework, then don't do it. That's fine. It's your option, your option. All right, let's go. We know who we are. Let's go ahead and first start by doing what? Distributing. Some of you guys are already doing it. I can see you. -6x plus 15 plus 1 is greater than or equal to 4. Okay. Go ahead and combine your like terms. On the left-hand side, you have -6x plus 16 greater than or equal to 4. Subtract 16 over to the other side. -6x is greater than or equal to -12. Here we go. Divide by -6. It doesn't matter that 12 is negative, but it matters that I'm dividing by a negative number. So when I do that, I need to flip the sign. When I get x is less than or equal to 2, put a little box around it. And then your book is asking you in your homework to graph these. Yes. So I would go to 2, and x is less than or equal to 2. So I start by deciding a solid dot or open circle. I'm going to go with solid because it's or equal to 2. And it's x is less than. Someone in my other class said this arrow points that way. Yeah. That only works when the variable is first. If I wrote 2 is greater than or equal to x, which is the same thing, my arrow's pointing the other way. Okay, so if you want to do that arrow pointing which way to go, it's only when the variable's first. You can't use it there. Okay, so x is less than 2, or you just have to think what numbers are less than 2. I got to go to the left. All right, you're going to try one. Number 4. Here we go. You get to try this. 2 times x plus 3. I'll give you an easier one than the one I did. Minus 1 is greater than 8. All right, you try this one. I want you to solve it, and I want you to graph it. You keep working. I'm going to go ahead and do it. 2x plus 6 minus 1. 2x plus 5. It's okay if you get decimals. Don't even worry about it. Subtract 5. X is greater than 3/2. A lot of you guys would rather write that as 1.5, which is fine. And then when you go to graph it, 1, 2. X is greater than 1.5. So I'm going to go to 1.5 and put an open circle. Open circle. Dang it. And then go to the right. Who got that? Let me see. There are about 25 kids who got this right. There you for the video. Okay, now, sometimes what happens, like on your quiz, you get something, you're like, what's going on here? My variables just canceled out. I did the problem wrong. No, you didn't. Did you get a no solution on your quiz today? Okay. I got no solution 5 times. Does that work? No. All right, number 5. Negative 2 times 3x plus 1 is greater than negative 6x plus 7. Okay, so sometimes that happens, and it happens in equalities too. We could get something that has, sometimes we'll have an answer, like the last one. That inequality is true when x is greater than 1.5. This one, let's find out. Is it true? Is it never true? Is it always true? Okay? So distribute, and you get negative 6x minus 2 is greater than negative 6x plus 7. All right. You can keep going. Add 6x to the other side, and what happens is your variables cancel out, and you get a statement that's either true or false. What is that? Is that true or false? Is negative 2 greater than 7? No. It's false. Okay, it's false, so this would have no solution, or you can say never true. There's not one single x that you can plug in there that's going to work in this inequality. Not at all. All right, let's see what the other one looks like. Number 6. 2 more to go. 5 times 2x minus 3 minus 7x is less than or equal to 3x plus 8. And they look normal, right? Like just like on the quiz, it was just mixed in with the rest of them. Looks like a regular old solving problem. So you get 10x minus 15 minus 7x is less than or equal to 3x plus 8. Show the work. And you get 3x minus 15 is less than or equal to 3x plus 8. If you want to stop there and you notice it right away, that 3 times a number minus 15 is going to be less than 3 times that same number and add it to 8. But if you wanted to keep going, you could subtract 3x, and you get negative 15 is less than or equal to 8. That's an 8. And that's a true statement. It's true. Okay, so this one is always true. You can say always true. You can say all real numbers if you want to. The question might be sometimes, always, never. The answer is always. What happens? No? Okay. Okay, last one. We're going to do a word problem. Because you guys like to ask why. Why or when are we ever going to use this? So they give you lots of word problems. Yes.
But I mean, because who knows?
Number 7.
Someday somebody's like, if you can tell me how far these cars get apart from each other going this fast, I'll give you $1 million.
There you go.
I can do it, bro.
Yeah, that's why you got to practice your half-court shot a lot, too, in case, you know, the time comes. Okay, number 7. All right, this is kind of an outdated problem. I like it, though. It's kind of fun. Let's say that you're going to rent some movies from a rental movie company. Blockbuster, yes. Do you remember Warehouse, the Warehouse? About Hollywood Video. Yeah, Blockbuster, me too. Okay, shh, shh, shh. What was that? Oh, okay. Got it. Let's say you're going to rent some movies. That says rent movies. I know, it's a little messy, sorry. And you have 2 options, okay? So this company is offering two plans. It's kind of like that swimming problem we did, where you got to give like a flat rate for the membership, or you could pay like a flat rate plus $1 a day. All right, so you're going to rent movies, and option number 1 is you can have an unlimited amount of movies. I spell unlimited. Is that 2 M's? No. Did I spell it right? Okay, bad speller. Unlimited amount for a flat rate of $36 for the month. That's expensive. Is it Netflix like a $8.99 or something? All right. Thanks. Thank you. Thank you for that. All right, number 2. Option 2 is you don't get unlimited movies. It's going to be $15 for the month, plus a rental of $1.50 per movie. Okay. So we're just going to go month to month here. We're not going to talk about how much it's going to cost for the year or anything like that. We're not going crazy. We're just going to compare 1 month's option, okay? So the question is going to be, how many movies must you rent in Plan 1 to like make it better than renting in Plan 2? So Plan number 1 is $36. That's it. No strings attached, no attacked, no crazy stuff, okay? So when is this going to be less than 15 plus 150 times m? 150 per movie. And what you do is you create an inequality to solve instead of an equation. Now, you could have set an equation to solve and solve it and then kind of think about it some more after that. But an inequality is fine too. So we're going to subtract 15. We get 21 is less than 1.5m. Divide by 1.5. 14 is less than m. A lot of people don't like it written that way. You might want to flip it around. Say m is greater than 14. So there's kind of a couple answers you can say. You can say more than 14 movies. Another acceptable answer would be what? 15 movies or more, right?
Yep.
Mm-hmm. More than 14. You're not going to do 14 and a half.
Well, have you seen Lion King 1.5?
No. It's a whole movie, though, right? If you were to rent it, you'd pay for the whole movie.
I'll bring it to you.
No, I'm good. I really am. Thanks. All right. Okay.